all of the people who are listening to this session are doing well. So today I'd like to talk about a brief experience of how it was to do Google Summer of Code 2024 under AsyncAPI. So just a brief introduction about myself. I'm Ankit Dash, and I'm currently a fourth year CS undergrad in IIT Karnataka, and I'm from India. So I did my GSoC 2024 in AsyncAPI, as I mentioned, and I worked on this project called as Dynamic Open Graph Preview for AsyncAPI Studio under Sergio Moya. Uh, Regarding my interests, I'm primarily interested in backend development, distributed systems, AI, and I like all things related to scalability, concurrency control, etc. If you want to reach out to me regarding anything, my email is given below. It's ankitdash2019 @gmail.com. So yeah, let's start with what is the motive and the need for the project. So as I mentioned here in the earlier section, it talks about dynamic open graph preview for AsyncAPI Studio. So AsyncAPI Studio is essentially the product where there is a text editor on the cloud, and users can write async API spec files in a text editor that is provided on the cloud, and it will essentially help in giving a good visualization on the side of the spec that the user wrote, kind of like how Swagger does it in a fast API application. So to understand what is the need of the project, we need to first understand what are open graph tags. So open graph tags are essentially a tag that is present in the head of the HTML of a page that decide how that page is going to appear when it's going to get shared on social media, on any social media site such as Twitter or Facebook or WhatsApp or Slack, anything for that matter. So the project involved essentially taking the um, Async API Studio file, Async API Studio's files that are in Async API Studio, and essentially when those files are shared, there is a URL that is created, and that URL that is created and when it is shared on the social media, it should dynamically show the content that the file represents. That is, it should contain certain metadata which gives the person with whom the file is being shared some information about what the URL points to before he or she opens the file. So the problem was that existing Open Graph tags for Studio were static in the sense that they did not really give any information on what the file contained or what the Async API spec Studio file that was being shared, what it contained. And my task essentially involved to ensure that the Open Graph tags are dynamic and they display relevant information when these URLs are shared. So the main key point that I think is very obvious about Open Graph tags is that regardless of the website, the main importance that these tags carry is that they increase the social media footprint and they increase the user experience and improve the engagement that is there with the website. So, right. Let's first begin with how I stumbled upon this organization in the first place and why I chose this project. So let's start the journey in the beginning. Before Google Summer of Code officially began and I officially was selected as a mentee. So the thing about me is that I started really late. Like Async API was a new organization that was chosen and it hadn't come in previous sessions of GSoC. So obviously I wasn't aware of the organization. And when the organization list was released, I looked up the list of organizations which would match my tech stack, and where the community is really helpful. And Async API seemed to be the perfect fit for that. So what I did was that originally the project that I wanted to contribute was something along the lines of a real-time collaboration in Async API Studio. but it was cancelled. So I had to choose another project. So this was another tough part because there are limited days left before I had to decide my project, understand the requirements, make a proposal, get it reviewed from the mentor, and go on this feedback loop till the mentor is satisfied with the proposal. So I had to find another project um, that I could actually do well in. And this project seemed to really catch my attention, primarily because I had not worked on something like this before. And it was really like the tech stack was something that that I have worked on, which I'll mention later in the session as to what the tech stack was. But the product or the improvement that I was trying to create was not just making another website, right? That is something that really motivated me to pursue this idea because and this was a problem which was not really easy to solve off the top of my head, and that was the main reason as to why I chose to go with this project. So a few things that I think really helped me for my selection was that I made some PRs in different repositories in the organization. So I guess few of the maintainers, they probably knew that here is this guy who has been making PRs, etc. So he might probably be interested in the organization. And also, I contacted my mentor really early, like just after the final project list was announced, where I chose this project. I think around 18th, the project list, 18th, I could find the updated list. And on 19th or 20th, I started contacting the mentor and gave him my ideas as to how I would approach it so that, I try to ensure that we both are on the same page. Um, then later, I try to make my proposal based on whatever my thoughts were, and I try to get it reviewed from my mentor as well. And he gave a lot of suggestions as to how this might not work, how a certain other thing might work, which I hadn't considered, or how I will deal with this particular issue. So there was a lot of refinement that happened in my proposal itself. And I think the main thing that my mentor noticed was that I had a lot of enthusiasm for the project, and I was willing to explore in new and different directions um, uh, of implementing this particular feature. So another thing that I think is very important is that when you're doing any internship or anywhere when you're working remotely, the main thing that matters is communication, right? You should have a good communication, a robust communication, and asynchronous communication as well. Um, because especially when there is time zone difference. So my mentor and I were like 3.5 hours apart. So you need to keep communicating so that you build that trust and the mentor trusts you that you will do the project um, even if there is not regular inputs given to you. So the basic thing was that I tried to be proactive in my approach and I tried to figure out as much as I could myself before I went to the mentor. So this is one of the suggestions that I'll give is that contacting a person has to be the last resort. It should not be like the first thing that you have a doubt and you're contacting the mentor. Try to figure it out for yourself. And if you cannot, then try asking the mentor. So, right. So, this was the project. And I had long discussions with my mentor. So, after I got selected in Google Summer of Code, I had long discussions with my mentor during the community bonding period and a bit of the coding phase as well. And the architecture that we came up with was as follows. Right. So what will happen is that when the Open Graph tags are shared, when the URL of the Async API document file is shared, what is going to happen is that each social media site has its Open Graph crawler, right? So what it happens is that it goes to that particular URL, kind of preloads some of its HTML, searches for the Open Graph tags if the HTML has any, and tries to replace the content that is there in the Open Graph tag in their preview image and the preview metadata that will be associated with the URL that has been shared on the platform itself. So this is what the Open Graph crawler represents. And this is the studio. This studio essentially represents Async API Studio. And this is a new service that I had to create from scratch, which was obviously part of the project, where um, yeah, which is going to essentially generate that dynamic image per se that you see in OpenGraph. So, because if I just go to a few slides back, you can see that there is this image that is associated with the uh, URL. So that image has to be dynamic. So that uh, metadata, the URL, like the title and the description, they have to be dynamic. And along with that, the image has to be dynamic as well. So right. So Open Graph crawlers. So how it's going to happen? So let's talk about it from an Open Graph crawler perspective. So when the document is going to be shared, it's either going to be a base64 encoded doc or it's going to be the URL of the file. So URL of the file essentially meant that you could, when you are going to share an async API document file, so it can either when you're sharing it, either the content of the file gets appended as a base64 string to the end of the URL as a query parameter, or another query parameter can be the URL of another file that you can point it to. So essentially, you can have studio.asyncAPI.com slash URL, like question mark URL is equal to something. And that URL essentially, let's say, points to a GitHub gist or a raw file, anything of that sort, which uh, which is essentially going to be the content with which you want to replace your Async API Studio's current Async API Studio's current screen with. So you will the Open Graph crawler will take the URL that you have shared, right? It's gonna hit Studio, load some of the metadata, then it's gonna set the Open Graph title and Open Graph description meta tags because these will be there associated with the URL itself, right? So, and this will be returned to the Open Graph crawler. So just to reiterate, the two things that are going to be shared with the Open Graph crawler are the title and the description, the Open Graph title and the Open Graph description. But another thing that needs to be shared is the Open Graph image as well. And how we do that, we will come to it. So to do this, the main key point is that these Open Graph crawlers time out really quickly because even if you try to share any URL which has an Open Graph, tags associated with the web page, these crawlers time out really quickly uh, because obviously it might be expensive to wait for a long time if the page is not loading or the Open Graph tags are not appearing. So this really turned into an optimization problem for me and my mentor as to how we will go about implementing this in the least time possible. So what I did was that the architecture that we came up with was that to send this pre-rendered Studio's HTML web page, we had to rewrite the request that was coming from Open Graph crawler to a separate route where the Open Graph related content would be extracted, right? And that content would be sent back to the Open Graph crawler. So here I used a word called rewrite. So let me explain what it means actually. So rewrite is essentially for a specific user agent when it's trying to hit a particular URL, instead of it. So our approach was that uh, uh, when there is a specific user agent, in this case an Open Graph crawler, when it is trying to access the URL that the user has shared, then it gets redirected to a separate route. And redirected is not the correct word here because it is happening internally in the studio's site itself, right? We are not redirecting it to a separate service. So we are rewriting the request to a particular route. And the specialty of this route is that it's just going to focus on the Open Graph related stuff. If you are extracting it directly from the studio URL, right, which the user has shared, the main problem is that Studio has a text editor, has a lot of nav bar, sidebar, etc., which is obviously for the user experience itself. But if an open graph crawler waits for all that heavy content to load, then the first contentful paint will be very late, and hence the crawler might time out. So to serve minimal HTML, we had the idea to reroute the crawler to this particular route, that is /API/crawler with the URL, so that we could, extract all the relevant information in that route. So the description and the title could be found out directly just by a basic parsing function which was written. But another thing that needed to be figured out was the image. So for image, what we did was that we tried to have another service which was hosted on cloud, and the image in itself is going to show a very limited set of things about the open graph, about the URL that is being shared. So it's going to show stuff like the number of servers that are present, the async API version that the URL, like the document which is encoded in the URL has, or the number of messages that are there in the async API file which is being shared, stuff like this. So stuff like this also has to be parsed, found out, and then it has to be put in an image, and that also has to be sent back. As you can see that this is, quite a time-consuming process, and there's high chance that the crawler might time out. So for that, image generator service also was deployed on Vercel, and we were using CDNs to cache the data aggressively, and we were also using edge functions, right? So because we were using edge functions because they will run very close to the user, and we were using CDNs primarily because of caching, and we were caching on the basis of query parameters. So as you can see that we will have the image generator service, and we will have this the relevant parsed information that we got in this rewritten route, and we'll pass a lot of that information as query parameters. So the image generator services task becomes really minimal. It is to have an open graph base image and just paste all this content that we passed in query parameter on the top of that image, and then send it back to the open graph crawler. So once that is done, it sends that image back to the open graph crawler as well. So I hope it makes some sense, right? So let's understand it from a user's point of view, how the user is going to, feel the changes. So a user, if they're going to AsyncAPI Studio, right, which contains a base64 URL, a base64 URL, or a URL query params itself that I mentioned earlier, right? If it contains that, then there is going to be dynamic rendering in the sense that we will fetch some of the content, right? We'll fetch some of the content, and then the page is going to render, versus static rendering in the sense we will fetch it directly from the local storage and will show it. So the way it happens currently is that AsyncAPI Studio stores your document in the local storage itself. So when you're trying to just go to the normal domain, that is studio.asyncapi.com, it will directly fetch it from your local storage, whatever the most recent file was, and paste it on the AsyncAPI file, AsyncAPI editor. But in case you're accessing a URL or a base64 encoded document, then it has to actually fetch that document, right? And this is a dynamic process. So in this, the parsing and all, etc., has to occur, right? So here, the dynamic rendering happens, and then the parsing process happens. So this is how, the process looks like from user's point of view. So let's come to the tech stack that I used. So a really nice thing that happened in this time was that this project would not have been possible had we were using client-side rendering in AsyncAPI Studio. So there was this huge effort that was undertaken by many of the maintainers of Studio that was essentially migrating the entire code from React to Next.js, essentially for server-side rendering, for avoiding waterfall problem, for minimizing those flashes that you see for page loads, etc. So we were moving to Next.js, and Next.js is one of the main reasons why this project was successful, because if it was not for Next.js, right, this pre-rendering of the server-side tags could not be done. It had to be offloaded entirely to the client. And first of all, going from a server to client itself is a network call, and that has to take up a lot of time. Plus, on top of that, the client has to load that entire page also. So offloading it on something as vulnerable as a client, as volatile as a client, is not a good idea. And because this entire generation of a lot of the content here is server side, that it is done already and it is kept. So it is done already and kept is actually static side generation. But I hope you get the point. A lot of the content is being generated directly on the server, which has a decent computational capability. And because that is being done, hence we can use these open graph, hence we can extract these open graph tags directly on the server itself, where the studio is getting pre-rendered. So, right. So, Next.js was mainly for its server-side rendering capabilities. Open Graph Protocol, which is the protocol that is used by Open Graph crawlers to extract the images. I used Brussels CDNs in Edge runtime, though there is also an effort from my side to move it eventually to Netlify, because Netlify is what Studio is hosted on. So right now it is currently hosted on Brussels CDNs and Edge runtime. And I also use Jest for writing unit tests and validating if everything that all the code that I have written has the expected functionality. Right. So this has been explained by me while I was on this this diagram, proposed architecture diagram. But just to reiterate and help us get on the same page. So the thing is that Open Graph crawler search for the meta tags, right? If the user agent matches the crawler, which is what I talked about. So if you are a user who is accessing the website right from the URL, there will be a dynamic rendering because URL has that encoded document which has to be extracted and put it on the AsyncAPI editor. But if it is not like that, then but even if it is like that, from a user's point of view, you are not going to see any open graph tags generation that is going to happen because that is not something that you are concerned with, right? If you're clicking the URL. But an open graph crawler is supposed to be concerned with that because before you click the URL, it has to show the necessary information, right? So if these are the params that are present, then we have to write it to the specific route. These are the specific route, right? In this, we extract the relevant information and we minimize the HTML. And then a lot of this information is passed on to the image generator service as query parameters. The image generator service then uses something called as Vercel Satori package to essentially paste a lot of this content on the image and send it back to the Open Graph crawler. Right. So this was a brief procedure of how this entire project was structured. We also came up with the architecture that I mentioned earlier after a lot of discussion and not just with my mentor, but with a lot of other stakeholders in the studio as well, as to if this architecture was feasible and if whatever we were doing, were we following the best practices and were we doing the right thing or not. So this was one of the main challenges that was designing the architecture. Then this issue of crawler timeout was always present. So we had to optimize as much as possible. Even the parsing function that I wrote, I had to ensure that I am trying to extract information as quickly as possible. So all the checks that that was done during the parsing function were like very easy checks that I had done, so that if in case it is not a valid AsyncAPI document or anything of that sort, we do not perform anything other than like at whichever point we find that it's not a valid document, we do not go to the further steps. So finding if something is right or wrong should be done at the quickest possible time. So this crawler timeout was one of the issues, and another issue obviously that we faced was that we had to serve the minimal HTML as well. And another issue that was there was after the migration from React to Next.js, there's a long response time that was present in Async API Studio. So this was primarily because I'm not sure with this because this issue was not really solved by me, it was solved by another contributor. But I think it was something along the lines of lazy loading and not offloading certain tasks to other threads along those lines. So I also did certain investigation as to why Next.js itself is taking Next.js Studio version is itself taking so much time to load. And if it takes a long time to load, then we again run into the same problem as I mentioned in the second point, that the crawler times out really quickly. And then there is this caching issue that we also faced, that caching on query params is not something that is done usually. But this was one of the needs that I had with the project. So hence that had to be figured out as well. And a main problem that was there on Netlify was that we were running it on Netlify serverless functions, as that's where edge runtimes run. And the main problem was that these serverless functions have a cold start. So there has to be a few hits to the serverless function itself to keep it warm, so that whenever an Open Graph crawler is going to hit the image generator service, it should not respond back after a long time. Otherwise, the crawler again times out. So the main issue, as you can see in any of the challenges that we faced during this entire project, was that after the crawler timeout. So right. So let's just discuss the result of the project. So earlier, as you can see, that there was this AsyncAPI Studio link. When it was shared, it just shows this blank kind of a templated text, which essentially tells what AsyncAPI Studio does. But now that it has been added, now that the relevant information has been added, you can see that there is this relevant title that appears, and on top of that, you can see whatever the text that is there, whatever the information that is associated with that particular URL also has. Like you have the number of servers, number of channels, operations, messages, etc. So this was the result of the entire project. So my key learnings during this entire project was that always try to start early, right? I was lucky that I started late and I could still end up with such a good organization where there are so many helpful people who are willing to help me and answer my queries at any time. And but I would still suggest you to start early and don't do it just for Google Summer of Code. Try to have the genuine passion for open source as well, so that you can stay in this area for a long time. And the most important thing, single most important thing is communication. You have to keep communicating with your mentor, with all the stakeholders of the project that they're working on as much as possible, right? They should never feel at any point that they have to question you or they have to ask you about updates first. You have to be very proactive in your approach and try to tell all your problems genuinely. Like, do not lie or do not hesitate to tell your problems to anyone or tell that if you're facing any issues, technical issues, personal issues, etc. And another thing is that you have to accept others' opinions gracefully. So in open source, the thing is that everyone can see your code, everyone can see your methodology that you have followed, and anyone can critique it as well. So you should always try to you should always try to understand what the other person is saying, where the other person is coming from, and if whatever he or she is saying, does it have any sense? And based on that, you should make an informed decision, because finally you are the one who is doing the project, but you should always at least listen to other people's opinions and then proceed with whatever approach you decide is the best thing for this particular project. So another really important thing is that you respect deadlines. So whenever you have committed that you are going to complete a particular task, try to complete it within that time, and do not, how do I put it? Do not take a lot of extra time. And even if you are taking extra time, inform the people beforehand. And very important thing that before you make a pull request, don't try to have a few unnecessary comments or a few log statements, etc., that are actually not required in production. And test your changes thoroughly before you actually make a pull request, so that there is minimal friction while minimal friction to merge your PR in the first place. So yeah, that's where my talk ends. So I would like to, uh, you know, acknowledge some of the people who really helped me along the journey. So, firstly, I would like to definitely thank my mentor, Sergio Moya. He was extremely helpful and extremely nice throughout the entire process, and he was very considerate um, to understand what problems I was facing, and he also was willing to put in the time so that we could both discuss the problems I was facing and how to solve them together. Then I would also like to thank Khudadad Numani. So he was one of the main stakeholders who I was talking to in the studio, and he is one of the code owner as well, maintainer as well. So he used to frequently review my PRs and give constructive suggestions, which I implemented in my PRs. And Aishat Mubuddin, who helped design the open graph based image that you see here, right, on the right. And this project would not have been possible without a lot of other open source projects like Vassal Satori package. And even while you're checking the user agent of the crawler, there is this project. I think it ends with something. I think the username of the GitHub username of the person who created the project, something like Monorepus. Apologies for that. I don't remember it clearly. But it would not have been possible if such people hadn't made such projects and open sourced it so that other people could use them for their projects. And also the entire AsyncAPI community and Google as well, which gave me such an amazing opportunity to contribute to this project. And apart from the technical things, a lot of the software engineering skills as well, like collaboration, like understanding deadlines, and communication. These are the things that I learned a lot, and I think this will definitely help me uh, in my future as well. So before I conclude the talk, I would like to just show a small demo as well of how. Right. Right. So as you can see, after I've shared, you can see that the URL is, with the help of the URL, I'm able to generate an open graph image, which contains all this necessary information. So yeah, this was the demo. I mean, I can show one more as well. So let's take the simple example one as show it here. So I think this is the account service example, and it should ideally work. I'm not sure why it doesn't work. If you wait for some time, you can see that the Kafka API, the Kafka document that was there, you can view that as well. So yeah, this is like a brief demo of the project that I worked on. Coming back to the slides, this is everything that I had to say. about my project. So thank you all for listening to this session. It was, a really great experience this entire summer. I learned a lot, and yeah, I would just like to thank Google and thank the entire community.